Hello. Today, we are going to be talking about how to make your embedded development process more thorough. Thoroughness is the third pillar in our consistent, automated, and thorough embedded development process, helping you, instead of getting in your way, get embedded products out the door on time and under budget. And being thorough means making sure that you've put your process through your product through the proverbial ringer, exposing it to all the possible inputs the world could ever throw at it. I mean, think about building a bridge. You got all the testing you got to do to make sure that it can handle wind, and rain, and fast traffic, and slow traffic, and cars bumping into each other, and cars bumping into the side of the bridge, and then people walking on it, and then bicyclists bicycling on it, and then there's rust, and there's sunlight, and there's fog, and there's boats, and so many different things that could possibly go wrong on a bridge. And when you got to design it and you build it, you got to make sure it can handle all those possible things. And then other stuff that you didn't even think of, like I didn't know seagulls had that much poop in them that they made the bridge collapse. Like, I mean, so you cannot just YOLO a bridge. I mean, you can. Anyways, all right, software. Just because you can't pick it up, you can't touch it, you can't see it, you can't smell it, you can't lick it, it doesn't mean that you should just YOLO your software. Now, some industries have put regulations in place to make sure we're not YOLOing our software. We're talking about aerospace, automotive, medical. These industries have figured out that software should be tested very thoroughly before it goes on the market. Heck, even big companies like Apple and Google throw large amounts of money at making sure their software is tested thoroughly. It is in our opinion at Tulip Tree Tech that everyone's software should be tested thoroughly, regardless of industry or application, and it shouldn't break the bank to do it. Also, you will find out that more thorough testing, specifically randomized testing, will get your products through integration and to production faster with fewer issues. Now, there are groups out there that spend hundreds of thousands of dollars a month, unbudgeted, mind you, this is unplanned for, just trying to get their product out the door because of bugs that they could have been found by randomized testing earlier in the development process. And how many times have you taken a perfectly crafted device, you plug it into the network, and then, didn't we even test this thing? What? So, how does it work? Well, you've got your unit and integration tests that cover your happy paths. And you make sure it actually does the thing you think it does. Specific inputs yield specific results. And then it's time for randomized testing. And this is where CodeForge can really help you out. We take the same input vectors and generate random inputs instead, and we see what happens. Is it going to crash? Is it going to drop into some unresponsive busy loop? Is it going to respond back with the wrong packets, the wrong messages? Fortunately, it's all in software, so we don't have to worry about the magic blue smoke escaping from it. In this video, we'll walk through an example of how to use CodeForge to generate randomized tests, run those tests, and then debug the failures that you find. Hop over to GitHub to follow along. We got a repo up there. You can check it out. All right. I'm Ryan Torvik with Tulip Tree Technology. Let's get your code in the forge. Okay, here we are. All right, last time, let's see, let's start here. So CodeForge extension is here. Get it today. Your favorite VS Code extension store. Go ahead and look that up, pull that down. All right, and then you're going to come here and we're going to need to initialize. So we're going to do that now. Initialize successfully. And you see here, there's no fuzzers found. So let's walk through the code real quickly. This project is a QP CPP. So we're using QP, the QP framework, which is a really cool embedded state machine style framework. So we've got 3 different fuzzers. We've got random bytes, valid packets, and valid packet and junk. Got some includes here. We're going to include the CMake file for the CodeForge QP CPP library. And then we're going to create a CodeForge fuzzer. And that's it. So for random bytes, we go down here, this LLVM fuzzer test1 input. And then actually just takes the random bytes that we pass in, make sure it's not 0. Like, come on, let's send something to it. Send bytes and process right up here. And then actually get thrown to our application, which we have these lovely unit tests for. So these lovely unit tests over here. That same application is being thrown to. So we're going to tell the application under test to go and receive these bytes, and then we're going to tell them to process it. Okay, and then the same thing here. We got one valid packet, but we're going to go through in a little bit more detail, and we're actually going to make a valid packet. Ping request, ping response, sensor data. If you're really curious how this works, there's a README down here that you can walk through, and then there's also a protocol documentation down here that shows you, like, okay, this is the protocol that we're parsing in this example. All right, so we actually create a valid packet and see how it responds to a valid packet with like a payload with the appropriate sizes and all this payload length, and making sure that everything is actually correctly, CRCs, checksums, and everything are actually calculated correctly. So, but you'll see, even though we're randomizing different fields in that protocol as opposed to in the random bytes, you're just randomizing the entire thing. If you imagine like, hey, I want to fuzz some Java, some JSON, I'm going to fuzz some JSON parsing, and then you just start throwing like whatever's in UTF-8. Just like, here you go, just whatever you want. It's like, you know, you're not going to get, you're going to keep getting stuck at certain points because it's not going to be valid JSON. So similar, we've shown that, like, okay, not only can you have random bytes, but then you can actually make a valid packet. You can structure, you can give yourself some structured protocol data, and then you can you know, like fuzz different fields in there. And that's kind of what we're doing in here with this one valid packet. And then we're doing like a valid packet and then some junk afterwards. So we're kind of combining the two, where it's like, hey, so I gave you what I think is a valid packet, and you, well, let's see how you handled it. And then let's see how you handle random stuff after that. And you can expand on this to town. We can just have it, okay, let's make one packet and then two packets and three packets and four. Let's try the packets in this order. And let's try the packets in this order. And let's see what happens when you handle this. You know, a lot of times unit tests will give you some good coverage and make you feel good about it, but you're not testing. And what happens, because when you plug this thing into the wall, like, it's going to receive packet after packet after packet after packet. Are you handling? Are you going to write unit tests that are going to go and like, okay, what happens if you get them all in this order and you get them all in this order? And what happens if this one's invalid? How do I handle this recovery? Like, there's just a lot of things that you don't necessarily think about. And the amount of time it would take to go through and enumerate all those is like, oh. So then you put in this randomized test and you're like, okay, do it for me. I'm sure you'll expose me to everything we need to do. So that's what we're doing. All right, so let's go here. We've initialized. I'm going to refresh this here. Scanning for fuzzers. All right, and it found them. I found my 3 fuzzers there. Let's go and let's just run the random bytes one. All right, so we're going to run it here. Fuzzers discovered, build successful, and then ran it. All right, so we've got stuff happened. There's all this output. Thank you, libfuzzer. It's been very helpful. Let's refresh here and see what we've got. All right, so we ended up running 357,000 test cases in that just a few seconds. Like, wow, that's crazy. And then we've got 8 different crashes that goes on. So you can go in here and let's see, we've got this one here. Let's look at this one. So we filled it. Here's a bunch of Fs, go to town. And then there's an AA here at the end. All right. And then what did you do? What happened? I don't know. There's the backtracer now. So we crashed somewhere in here. And you can do this. You can go and like, all right, let's look at random bytes here. Okay, it was in the process bytes call. And then, oh wait, hold on, where'd it go? It went away. No, there it is. And then it's in smp.cpp, and so it's posting over there. And then let's see, it's somewhere in here. Okay, neat. So you can look at it this way. Look at the bytes there. You can look at it this way here. That's okay. That's one way of looking at it. If you want to print this out, turn it into a PDF, mail it to your boss, whatever, you can do that. We'll mail it to a friend of yours. Like, hey, what the heck? I thought you said you tested this. Blah. You can do that. Well, let's see also here. You can do this. Click on this button. Then I'll actually open it up in GDB. And we've got the application there running, and it's loaded with the crashing file that we've got. We can actually run forward, and then, oh, there it is. There's our crash. We can do our backtrace, and we can actually, if you really like command line GDB, because you're super cool and very low-level technical and excited about command line GDB, you can go ahead and do that. Yeah, here it is, her error. I thought it would not error, but it errored out. Test exit. That's okay. And there's our post. There's our process bytes. You can even print. Let's see. Where are we at? We can print our bytes. There's some bytes. I really like doing command line GDB because I like to. There it is. Woo! All right, so you can do that, or you can click on this little worm here. Ant. Is there an ant? This looks like an ant. All right, there's an ant. And it pops up GDB server, and then we connect to it. And just to show you a little bit what we can do, let's start over here and let's put a breakpoint in at the set. Oh, there it is. Got a breakpoint in it set up, and then we're going to go ahead and play. Boop. So there it started and set up. We're going to go, let's see, step over. Size is not 0. Okay, we're going to step into this. Send bytes in process. Step over, step over. You can step into any of these things. Puts it in the buffer, super exciting. You can put other breakpoints there, you're really using it, like you're using it in VS Code. And then we can continue here, and then there's our break, and we can step up into our stuff, and we can see, okay, here's E. All right, so we got our signal there. What are the bytes that we sent in? Like, you can actually look at the bytes here, look at the register values, look at all those registers. Woo! Register values there, bytes, the length is 211. So you can actually take a look at these things and kind of put them in the watch. You can use it like you would use a regular debugger. Kind of break down and see what this is. All right. And then we can do the same thing. We got the other ones over here. I'm going to say disconnect. We're going to stop that. So disconnecting will mash that GDB server, take care of it, knock it out of the way, so we're done using it. And you can do that with any of those crash files that you see. And you'll see, if you're doing this on your own, and you're doing your fuzzing, you'll see, I mean, you saw that output, like, wow, that was really helpful output. Thanks, libfuzzer. Like, oh, geez. And also does a lot of corpus stuff. Like, here we are, a lot of corpus, like a lot of different files. These are all the different inputs that caused interesting things to happen. And so, yeah, it's like, oh, okay, this is neat. But there they are. If you want to look at them, those are the files that we've gotten here. You can do valid packet. So let's look at just one valid packet. Running that there, discovering. Okay. Same stuff. It's got input. We're going to go over here, refresh that. Okay, there's our random bytes. And there's our one valid packet. Similarly, got 8 crashes, another 381,000 test cases, random inputs. And you can go and see, like, okay, what did you come up with? All right, here's our valid. Well, this is I should be clear, this is not the actual packet. As we saw in our random packet here, let's see our valid packet. One valid packet. You'll see that we took that, instead of just taking the data as it is, we've actually got it and we make a valid packet, kind of using that data. And so you'll see that, oh, we put a ping request in here, ping response. So really the best way to understand the data that actually got through is to go through here and look at the bytes as it's going through and kind of watching. Let's see, this is one valid packet. So we will come over here and there we go, step in there, and then we're gonna go setup, and then we'll step over, step over, step over, step into, and then we'll kind of look. All right, what are we gonna choose? Output 0 is not the sync byte. What is output 0 then? Okay, looks like it's not the sync byte. The sync byte is that. Let's see, what is the sync byte? Double A. Okay, so double A is what the sync byte is. And that is not happening here. So we're going to actually put that in there as the sync byte at the beginning. So the output has that 252. And then we'll go through and say, okay, message selector. So we took our first byte of our input and said, going to mod that with 6, and then we'll have one of these here. So what is our input message selector? What is that? 2. So we're going to see it's going to create a sensor data request. And we're going to step over, and there it is, sensor data. So this is really the best way to kind of go through and say, okay, what kind of packet did we actually come up with? And you can see, you can walk through the logic and see this is the packet that we sent that caused this issue. And then you can go through and debug it and say, okay, if we send a 2, what do we expect? And then you can hop over to your code over here in SMP, and you're like, all right, I was expecting a sensor data. And then you go over here, and you're like, okay, so this is what we're going to pull apart all this stuff and see what actually happens. And you can debug this whole thing, kind of step through and see what actually happens with this. But you'll notice that we probably don't even get this far to parsing center data. Let's try. Let's just try, see how far we get. Let's run it and see. Do we get to that? Nope, we got to CodeForge. So this is why it's important to try to debug it, because you might think like, okay, it's my sensor data, so let me go and look at my sensor data, but it's not even getting this far. So I encourage you to go through. You can follow along at home. What we've seen here, there's a CodeForge QP CPP example that you can pull through and like, okay, go ahead and put that in there. You can actually run through it yourself and kind of debug it and see what the problems are in there. And you'll see there's some things in older versions of QP. We're relying on a specific version of QP, just because like embedded systems, you don't always update to the most recent libraries. You've got to stick to this one because of what features it has, what you're used to testing, what's been approved by your customer, or what's been approved by your team to use. So you might get stuck with an older version and find out that, oh, I don't know, this is a uint 8 instead of a uint 32, which is what I thought it was, but it's a uint 8, and then so I'm shoving the size in there, and it turns out it's clipping it off, and then we're getting a lot smaller than I thought I was going to need. So go check it out, go walk through it. All right. And that's it. That's how you use CodeForge to run a fuzz test and kind of examine the results of those fuzz tests as well, because running it by hand, oh, very intimidating to some extent with the amount of stuff, what's a corpus, what's all this output, what are all these different crashes for? How do we actually debug this and run through it? How do you take the output like, oh, this is really helpful. This is not helpful at all. Like, come on, man. And then if you see like, let's say that, you want to run this, like there's so many different, so jump into it with CodeForge, check it out here, and then we'll see. Well, hopefully it makes your life a lot easier to integrate this into your pipeline. And that's it. Remember, test your software and your firmwares thoroughly. Write unit tests, use test-driven development, and then put fuzz tests in your process. Hammer out those bugs early, and beat your competitors to the market. If you don't know where to start, reach out to us. We're on the LinkedIns, we're on the YouTubers here, we're on other things, I'm sure. Drop a comment below. We are more than happy. We are excited and willing to work with you on the problems that you're seeing and how you can actually get your software tested thoroughly so you can get to market faster. You can stop having so many issues in integration and in production and in the real world, and hammer out those bugs early. All right? I'm Ryan Torvik with Tulip Tree Technology. Let's get your code in the forge.